Hey, today we'll be talking about a bit of balancing chemical equations and mostly about calculating the amount of reactants in a chemical reaction. So yeah, let's begin. Consider the combustion of methane. Basically this. To answer this, we first have to balance this equation. But as you can see, it's already balanced. Yeah, it's actually already balanced, so let's skip right into the question. How many moles of CO2 will be formed from 2 moles of CH4? To answer this, you ha the equation tells us that for every 1 mole of CH4, there will be 1 mole of CO2. Uh, if there's no coefficient here, that usually means that its value is 1. So basically, if this here is 2, this here is also 2. That's why the answer is 2 moles of CH4 would form 2 moles of CO2. The formula the formula for this is actually quite simple. So since it's asking how many moles of CO2 will form when 2 moles of from 2 moles of CH4, what you're gonna do is you're gonna take the given mole, so which is 2 moles of CH4. Let's actually write that here. So 2 moles of CH4 divided by the original, the balanced mole of CH4, which is 1. You divide it, you get 2. You then multiply it by the balanced mole of CO2, which is 1 as well. So 2 times 1, you get 2. That's how we got 2 moles. That's how we got this answer right here. But what if the equation is not yet balanced? For example, this is equation. So we first have to balance that. Can I copy and paste that? No. Yes, I can. That's so lovely. Hmm. How do I move it around? Okay, let's just place it there. Let's erase this. All right. So we first have to balance this equation. I will actually already balance this a while ago, but to give you an idea of how I balance it, so basically we're just gonna put C here, H, and O, as well as C here, H, and O. As you can see, you can skip this part if you already know how to balance it. But for those who are struggling, this is basically what I do. As you can see here, 4, 10, 2, and that will be 1, 2, and no, actually no. Our oxygen should be 3. Well, whereas for hydrogen it should be 1. Yeah, I think no, actually no. Our oxygen is 2. Our hydrogen is 2 actually. So there we go. So now, what can we multiply here to get this to 10, which is 5, right? But if we add 5 here, the hydrogen will be balanced, but the carbon and the oxygen are still unbalanced. So now we have to think of the carbon here. If we add 4 here, if you add 4 here, they will be balanced. If you add 5 here, they both will be balanced. But if you add 4 here, you also have to multiply 4 here rather. If you add multiply 4 here, you also have to multiply here, which actually no. Let's actually divide. Let's actually yes, like that. Let's actually separate them. You have to multiply 4 here, which becomes 2 times 4, 8 plus 1, 9. And you also have to multiply this by 5. So 1 times 5 is 5. That becomes 13. But 13 is an odd number, and we can't really add anything. I mean, we can add 6.5 here to get 13. So 2 times 6.5 would get us 13 actually. But uh, our coefficient should not be a decimal, it should be a whole number. So what we should do is I mean, right here we already have a balanced equation. But since one of our coefficient, our oxygen, is has a decimal, we'll have to multiply all of them by 2. So here we multiply 6.5 by 2. Wait, how? Okay. This now becomes 26. Or rather, since we multiply 6.5 by 2, let me just erase that actually. This now becomes, this now becomes 2 times 13. So now our oxygen is 13. That will also mean that we'll have to we'll have to multiply these by 2. So now our 4 becomes 8 and our 5 becomes 10. So it's now 2 times 4 equals 8 and 1 times 10 equals 10. Wait, wait a second. 10. I think I'm missing something here. No, wait, no. This becomes 8 actually. So 2 times 8 equals 16. Sorry for that. So 16 plus 10 is 26. 2 times 13 is 26. Our oxygen is balanced. There we go. So if we add 8 here and 10 here, that would make our oxygen balance, but then that would not, our carbon and hydrogen are now unequal. So what we do? We add 2 again. We multiply 2 again. So here we put 2 here. Oh, wait, no. Oh, we write 2 here. So that would mean 2 times 4 equals 8. And we're just gonna have to erase this. We now add 8 here. Since this is 8, we also have to multiply it by 8. So equals 8. So now our carbon is balanced. Same with the hydrogen. 2 times 10 is 20. And it's 20 actually. 2 times 5 is 10. But since we multiplied by 2, we multiply our 10 by 2. This is 20. So now our equation is now balanced. I'm sorry for this messy drawing. I don't know. But anyways, yeah, we finally balance our equation. And now it's time to calculate for this, to answer this question. Calculate the moles of H2O formed when 1 mole of butane, C4H10, undergoes combustion, right? So to do that, okay, I'm just gonna, let me actually make another one here. All right, so 2, 13, 8, 10. There we go. So CH410. So it's asking when 1 mole of butane undergoes combustion. So from this equation, we can see that for every 2 moles of C4H10, there is 10 moles of H2O, right? 10 moles of H2O. Now, so if there's if 2 moles of if 2 moles of C4H10 gives us 10 moles of H2O, and then that would mean that 1 mole of C4H10 would give us 5 mole of H2O. And so the answer is moles, 5 moles of H2O. And to prove my answer, we're gonna follow our what do you call that? Our formula. So again, we divide. Uh, wait, no, actually, yeah. So we use the given, which is 1 mole of butane, and we then divide it by the balanced mole of butane, which is 2. So now we divide 1 by 2, we get 1/2. So yeah, 1/2. We then multiply 1/2 by the original mole of H2O, which is 10. So again, basically the formula is x divided by y, where x is the given mole. Actually, don't know how to the exact term for this. I'm just making stuff up. And the balance mole of that given mole. So the given mole here is 1, and the balance mole here is 2. So 1 divided by 2 equals 1/2. And after you get the quotient for that, you then multiply it by the balance mole of the of what you're trying to calculate. So 10 mole, so 1/2 times 10 equals 5 moles of H2O will be formed if there is 1 mole of butane. And yeah, pretty simple. You you have to balance the equation first. After you're balancing it, when you start to that's when you're able to calculate it now. And same here as well. I think is this already, but no, this is not balanced yet. But anyways, yeah, as you can see here, let's try to prove why the answer is 6 moles. What do we add here to make it balance? Hydrogen is already balanced, oxygen is not balanced, so we add 2 here. Wait, I cannot copy and paste that. Anyway, we add 2 here. So just imagine that there's a 2 here from where my cursor is pointing at. So now from the balance equation, it's telling us that for every 1 mole of oxygen, for every 1 mole of O2, we get 2 moles of H2O. Again, imagine that there's 2 here. You know what? I think I'm just gonna write it. H2 plus O2 equals 2H2O. Since this is the balance equation, That's the balance equation. So now it's telling us that for every 1 mole of O2, we get 2 moles of H2O. So again, we divide using this formula, given mole divided by the balance mole. So our given mole is 3. Okay, 3 divided by 1, since our given mole is 3 and our balanced mole is 1. It should give us 3 times what we're trying to calculate, the mole of what we're trying to calculate, which is 2 equals 6. So now the answer for this is 6. As we can see, we managed to prove it. Same here as well, you just do this, like you can try this. I already answered this. You guys can try it if you want to. But let's just skip this for now and let's move on here. Now, there's actually a difference here. As you can see, it's asking for the grams instead of the moles. Uh, our previous questions or examples, the mole is already given, but here it is the grams. So what do we do? Again, if you learn empirical formula by now, you should know how to convert grams to moles. I assume you guys know. That's actually right here. So, how many moles of PbCl2 will be formed from grams? So we're gonna convert this. I mean, first we'll have to what do you call that? We'll have to balance this. Oh my God, we'll have to balance this again. And I cannot copy and paste. So I'm just gonna write it. PbNO3. Again, if you guys already know the balance equation for this, or you already know how to balance, you can just skip this part of the video and then straight to where I explain how to get the answer. PCl2 plus nano 3. Let's see here. So our Pb, our NO, nope, they're separate. Our N and our oxygen. Sodium and chlorine. There are actually 5 elements. 1, 2, 3, 4, 5. Yeah, there's 5 elements. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. Pb, nitrogen, oxygen, sodium, chlorine. Okay. Let's balance this. Our Pb, what was our Pb again? That is 1. Same here. It's 1 here. Our nitrogen is 2. Our oxygen is 6. Okay. Our nitrogen here is 1. Our oxygen, however, is 3. Our sodium here is 1. Our sodium here is 1. Chlorine, 1. Chlorine here is 2. As you can see, only Pb, I actually don't know what Pb stands for. Lead. Okay, good to know. Our lead is already balanced. Same with our sodium, but for the rest, they are not. So let's start with our nitrogen. Start with nitrogen, so we're gonna add times this by 2 to balance them. So we're gonna add, why the why did I not leave space again? Wait, if I do this, okay, let's undo. If I do this, aha, magic. There we go. Anyway, so if we add 2 here, so now our nitrogen is now 2. That is not negative. It's equals. There we go. We also have to multiply our sodium by 2. So now this becomes 2. Same with our oxygen, actually. 2, so now our oxygen is 6. So now our nitrogen equals or balance. Same with our oxygen, they are now balanced. Same with our lead, and now we only have to balance sodium and chlorine. So to balance them, we just have to add 2 here actually. So if we add 2 here, so now they're balanced. 1 times 2 is 2, 1 times 2 is 2, they're balanced. Same here as well. Yeah, so now they're all balanced. So this is the balance equation. My God, I can't. My oh, the handwriting sucks. Anyway, how many moles of PbCl will be formed from 45 grams of NaCl? As you can see, for every 2 moles of NaCl, we get 1 mole of PbCl2. To convert, we remember to convert, we first have to get the molar mass of NaCl. So Na molar mass, Cl molar mass. So basically 35.4. You know what? Basically, we just have to add this. Let's round this off to 23. 23 plus 35 for 0.453. I think that should be somewhere around 58. I'm not sure. It's actually 58.44 there actually. For 24, but you know what? But since we did we round them off, so we're gonna actually gonna use 0.45. I mean, it depends on what is said on the test paper. If we have to we have to, what do you call that again? We have to round them off or not. But anyways, wait, oh shit. Anyways, oh wait, oh, sorry. This is it, yeah. For 58.45. I mean, you can also use 58.44, but again, we're not allowed to use our predictable, and I mean, yeah. Anyways, you just have to you just have to add the two anyway, and then get the total molar mass for both of them. After that, you do. Okay, so first you're gonna get the grams of NaCl, the given grams of NaCl, so which is 45, and then you divide it by 58.45. 58.45. So let's go to, okay, wow. So 48, wait, no, was it 48? 45 actually. Divided by 58.45 should give us 0.769. Round that off to the nearest hundreds. We should get 0.77. Should get 0.77. So now, this is our mole. This is not the answer, but that is our mole for our NaCl. So now, how many moles of PbCl2 will be formed from 45 grams of NaCl or from 0.77 moles of NaCl? And since we already know that for 2 moles of NaCl is 1 mole of PbCl2, we already know that to get the answer, we'll just have to divide this by 2. So we're just gonna have to divide it by 2, and the answer should be 0.77 divided by 2. That should be 0.385, I think. Yep, 0.385. So 0.38. Okay, I cannot. There we go. 0.385. As you can see, you have the same answer, 0.385. And to use my formula, the given mole divided by the balance mole. So the given mole is 0. Okay, why can I not write again? 0.77 divided by the balance mole, which is 2. Actually, this is what we're doing right now. 0.385. And after that, we multiply it by the mole we multiply it by what is asked, what we're calculating for. So PbCl2, the balance mode for PbCl2 is 1. Is it 1? Yeah, it is 1. Times 1, we get 0.385. So yeah, that's basically the answer, 0.385. One last, okay, so one last, okay, ooh, this is interesting. Anyway, one last equation. Let's try to solve this together. We Let's try to solve that together. I think the balance equation should be okay. So if you guys already know how to balance this, you can go ahead. I'm just gonna use some magic. I don't wanna spend enough time as it is on balancing. So the balance equation for this should be 6 here, 6 here, and 6 here. I believe, I think, maybe. 6 times 2, 12, 6 times 6, 6. Yep, 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 yep. Anyway, how many moles of CO2 will be formed using 200 grams of C8, C6, H12O6? So again, we're just gonna have to search for a molar mass or molar mass of C6, H12O6, which is 108.156. 56. I mean, you can also just search for the molar mass for carbon, molar mass for hydrogen, and with hydrogen, oxygen, yeah. Hydrogen molar mass, and then oxygen molar mass. And if you add them all together, okay, so let's just round them off. All right, 12 times 6 plus 12 times 1. I think hydrogen is 1, yep. Plus oxygen is 16 if you round it off, yep. 6 times 16 should give us 180. If we round them off, that is. So yeah, let's try answering uh, with the value rounded off. You can also try answering with the value not rounded off. Uh, Again, it just depends on what is written on the test paper. But yeah, anyway, let's see here. So we'll just have to again convert the mole into grams. Convert the grams into moles. Sorry. So 300 divided by 180 should give us, what does it give us? I think it's around 300, 180, well, no, not one half, more than one half actually. Is it more than one half? 1.66. Let's use 1.67. Let's round it off to 1.67. So now, again, we look at the equation. How many moles of CO2 for missing one? So for every 1 mole of this, we get 6 moles of CO2. So basically, if this is 2 moles, if this is 2, then this becomes 12. But it's only asking for 1.67. So the answer to that, again, we're gonna use the formula. So the given mole divided by the balanced mole, given mole divided by the balanced mole, 0.67 divided by 1. I don't know why I divided that. I mean, the answer is literally right there. Times 2. No, 6 actually. 10.02. The answer should be. Oh, wait, no. So times 2, since 2 is the. I know, 6. Why do I keep saying 2? So yeah, 6. Here we go. 6. We should get 10.02 moles. Again, the answer can vary. There should be a difference of like some decimals if you round them off or not. Depends on whether you round them off or not. But basically that's how you get the answer. And yeah, that's it basically. It's pretty simple. Bye.